Okay, so we have four different types of languages. Type 1, sorry, starting from type 0. Okay, type 0, type 1, type 2, and type 3. So we cannot say that type 0 is the lowest and it keeps increasing, not like that. So here type 0 is the highest form of a language that could accommodate more number of strings. Okay, and the machine related to that will be able to accept different kinds of strings. So what actually we are going to study here is now the first one, the regular language or the type 3. Okay, so if you So if you could see here the regular language or the type 3, that is the innermost in that hierarchy. Okay, that is the least one. Okay, we can say that this is the least one in the Chomsky hierarchy. And so this regular language is what we are going to study now. Okay, so if you see the regular language, so each of the language will have an associated grammar and it will have an associated automaton, or we can say it as a machine. Okay, automaton or a machine. So automaton is the abstract model means they have it in idea. Okay, they have it in a concept or an idea or a thought, but it is not physically existed at that time. Okay, it is all mathematical concepts or ideas. So this regular language will be represented by a accepted automaton. Okay, we can call it as there are two types of automaton for that. One is deterministic finite automata and another one is non-deterministic finite automata. Okay, so we have deterministic finite automata as well as non-deterministic finite automata. So we usually call it as DFA and NFA. Okay, DFA and then NFA. So okay, so deterministic finite automaton and another one is non-deterministic finite automaton. So these are the two automaton or the machines that is going to represent the regular language. Okay, so now let me give you, I think ma'am would have already explained you what is deterministic finite automaton. So now just I'll recollect that back to you. Also, I'll give you the definition for NFA and I'll tell you what is the difference between these two. And what we are going to study in the upcoming classes is that so since both of these are able to represent a regular language, we are going to prove that these two are equivalent. Okay, so we are going to prove that both this DFA and NFA are equivalent. So by that way, and also we have in the previous classes, we have studied about the regular expression. Okay, so regular expression is also another form of or another notation to represent this regular language. Okay, so what are all the things that we are going to prove is that all these are going to be equivalent. Okay, so you will be able, if you are having a regular expression, you will be converted to NFA. Okay, and if you have an NFA, then you will be able to convert it into DFA. Okay, so all these conversions we are going to study in the upcoming classes. Okay, so now I'll start with the definition for DFA as well as NFA, and I'll give you the difference between both of them, and also we will see some of the examples for that DFA and NFA. Okay, is that clear? Any doubt regarding this? Do you understand? Are you all present in the class?
Yes, ma'am.
Do you understand it?
Yes, ma'am.
Yes. See, when we ask something, if you could respond, please, it would be good for us also to so that move ahead, knowing that you are able to capture the concepts. Or even if you don't understand, kindly ask questions. One second, I'll share the. One second, I'm trying to connect your camera board. Kindly wait, ma. I'm not able to connect the board. Uh, are you able to see the board? But is it visible in the right way or in the how it is visible, ma?
Ma'am, we are not able to see the D of determinate.
No, but is it coming in the right way or in the
Yes,
reverse?
ma'am. Yes, ma'am. It's coming the right way.
Right way only, not in the reverse, right?
No, ma'am. It's correct.
Okay. Now is it visible, ma?
Yes, ma'am. Yes.
Yes, yes. Thank you. So please tell me if you're not able to see what I'm writing, okay? Please have your notebook with you. Please don't simply sit and listen. It will not help you much. Take notes in your notebook. So what we are going to discuss is about the DFA and the NFA. Okay. So already you would have, ma'am would have taught about the DFA. What is the concept of that? I'll quickly recollect all those things and I'll give you the difference also. Okay. So for a regular language, okay. So if you want me to write a little big or to little clearly, please let me know because only if you give me feedback, I'll be able to improve it. If you're not able to see it properly, or if you want me to write it little big, whatever it is, you can please tell me. Otherwise, is it okay now?
Yes, ma'am. It is okay.
Yeah, thank you, ma'am. So, as I told you right now, the regular language it can be given by the two machines DFA, that is deterministic finite automata, as well as the non-deterministic finite automata. So these two are the automaton or the machine. Okay, automaton, that is an abstract model of the digital computer. Okay, so and this another notation that we have already talked about is the regular expression. So after studying all of these DFA and NFA, so we will also be trying to give you the equivalence of all those things. Okay, because all these representations are representing a same regular language only. So we'll be able to equate regular expression, or we can have, create an equivalent NFA for a given regular expression. And when an NFA is given, we'll be able to convert it into a DFA. Okay, so so these things also we will be studying after this. So now let me tell you what this DFA is and what the NFA is. I'll start with the definition of that. If you start from here, is it visible?
No, ma'am.
No. Good now?
Yeah,
Yes,
ma'am.
ma'am.
Yes, thank you. Okay, so DFA, so to simply understand, the term for D is deterministic. Okay, so that means there is only one way. Okay, there is a determined way, only one possibility. Okay, there is no other way. So for example, you can take two states. Okay, one is on state and another one is off state of a switch. Okay, you can take on state and off state of a switch. So if it is in on condition and if you push the, okay, then it goes to off state, correct? And while it is in off, if you push, okay, so push is the input you are giving. Okay, push is the input you are giving. So again, if you are pushing, then it goes to on state. So this is the meaning of deterministic. Okay, it is determined, or from this particular state, if you give this input, definitely it will go to the this particular state. You will be able to say it very deterministically. Okay, so that is called as the deterministic finite automata. Okay, so so from on state, okay, on giving some input, there is a transition happening to another state. Okay, so a process, okay, a transition is happening and you are moving to another state. Okay, so so now how this DFA is represented is, it is represented by a quintuple. Okay, it is represented by a quintuple. So M is equal to Q sigma delta Q naught and capital F. Okay, M is equal to, the machine or the automata is described by a quintuple. That means 5 elements are there: Q, sigma, delta, Q naught and capital F. So if you are going to do with NFA also the same thing. Okay, so for NFA also we have all these 5 elements. But what is the difference? I'll tell you. So before that, what is NFA? NFA means non-deterministic. So from one state, if you are doing, if you are in state 1, okay, if you are in state 1, when giving a particular input, there is we cannot say deterministically that it will go to this particular state only. Okay, so it will have some choice of moves. Okay, it is having choice of moves. So for example, from this state 1, if I give input A, it may go to state 2 or it may go to state 3. Okay, for the same input, it may go to 2 or it may go to 3. But in the case of DFA, it is not like that. Okay, from this state, if I give this particular input, definitely it will go to the state only. Okay, so that is what the thing, the difference between DFA and NFA. In NFA, we do have some choice of moves. Okay, so the transition, we cannot deterministically say that this will go to only this particular state. Okay, so for a same input symbol, there are different choices of moves. Okay, so that is called non-deterministic. So now this DFA and NFA both are represented using the quintuple, the same kind of elements, but the difference lies in this transition function. Okay, so let me tell you what this Q, sigma, and so on. Okay, Q is what is Q? Q is the set of finite internal states. Okay, a finite set of okay, like as we have seen this on off, these are all states. Okay, finite set of internal states, and sigma is the input alphabet. If my writing is not clear, or if you want to make it make a change anywhere, you please let me know. So sigma is the input alphabet. Okay, so it may be either you can take A comma B, or you can take the binary alphabet 0 comma 1, anything. Okay, any alphabet. And then comes the, okay, this transition function we will see at the last. So Q naught. Okay, Q naught is the initial state. So from where the transition will start. Okay, so usually this initial state will be represented using an arrow mark before the state. Okay, so for example here the arrow mark will be given before the initial state. Okay, so this is the initial state, and then we have capital F, which represents the set of final states. So what is the meaning of final states? Final state is that, so when a language is given, the language will have some strings or the sentences in it. Okay, so if you are able to start from the initial state, and if you are able to reach the final state, and you are able to read that particular word or string from that language, that is the final state. Okay, so in that automata, you start from the initial state and you keep transitioning. Okay, you keep moving to different states, and if you are able to read that particular string in that transition, and if you are able to reach and if you're able to read that fully completely without any hindrance, and reach the final state, that is called final state. Okay, so F represents the don't worry if you don't understand this. When you see the example, you will be able to understand. Okay, so as of now, you just make a note of all these things. And now we have one more thing we have left, that is the delta. Okay, so this is represented using the this delta is nothing but the transition function. Okay, delta is the transition function. So the difference between DFA and NFA lies in this transition function. Okay, how the transition happens from one state to another state. Okay, so the transition of in DFA, how the transition will happen, and in NFA how it will happen. So for example, in DFA, okay, so what I'm going to tell you is here DFA. Delta is defined by Q into sigma gives Q. Okay, Q into sigma gives Q. So what is the meaning of this? So now we have seen that Q is the set of internal states. Okay, so for example, we have taken on as a state, off as a state. Okay, and this sigma is the input alphabet. Okay, so any symbol from the input alphabet. So for example, we will take that example itself. So what I can tell, the transition of, okay, this delta symbol, it represents the transition. Okay, transition of state, let me take the on state. Okay, if the state is on and if the symbol is push, okay, if I push it, then where it will go, can you give me the answer? Can you give me the answer for this? Currently the state is in on state. When I give the input as push, to which state it will move on? You can give an yes, thank you, good. Christina, good. Any others? Others also you can give the answers. Yes, it goes to the off state, right? So this is what the transition function here represents. So it is, so this Q represents the set of internal states. So what are the states we are having for that? But in this particular example, we have seen we have two states, one state is on and another state is off. Okay. So transition from state on giving an input symbol push, it goes to a state off. Okay, so this is what the transition function of deterministic finite automata. Delta is given by Q into sigma gives Q. Okay, so any state taken from the set of internal states and applying some input symbol from the given alphabet, it gives another state or the same state from that set of states. Okay, so now this is about DFA. Now coming to NFA, and here lies the difference between NFA and DFA. So here the transition function is represented using Q into sigma union lambda gives 2 power Q. Okay, so I'll tell you the meaning for this. So now this you know, right? From a particular state in the given set of internal states, and when you give some input from the input alphabet, any symbol from the input alphabet, and here along with that we are having another option also, that is you can have an empty string also as the input. Is it clear? You can have also an empty string. Lambda is representing the empty string. Okay, and another symbol that we use for empty string, anyone can say? You can unmute and say what is the another symbol we will use for empty string. Not phi. Phi is for empty language. For empty string, yes, epsilon. Very good. Okay, lambda or epsilon. Okay, so what it means is, so for example, as we have seen sigma is equal to 0, 1. Okay, if you are taking some binary input. Okay, if you're taking the binary alphabets as binary symbols as the alphabet, then your sigma contains 0, 1. Apart from this, you can also use empty string as an input during a transition. Okay, so how it could be delta of, so you can take any state. Let me take some state as Q naught. Okay, let me take a state name as Q naught, comma, you can take the Monish, you want to ask anything? Monish, kindly unmute, or if you have any doubt, you can ask. Okay, please listen now. So Q naught so you can have either 0, okay, or 1, or even you can have a transition with an empty string. Okay, so this is possible only with the NFA. In DFA, you cannot use an empty string as an input symbol. Okay, so lambda is not possible in the DFA. So what is this 2 power q? Okay, so this means the power set of q. So why we are having a power set over here is that, as I told you, that in NFA you have some possibility of moves. Okay, there are choices in the transition. So for the same input symbol, okay, you can either can have Q1, or you can go to Q1, or you can go to Q2 also. Okay, so from the same state, let me take it as Q naught. Okay, there is a state Q naught. So for input symbol 0, I can either go to state Q1 or I can go to state Q2. Okay, so there is a possibility of moves. Okay, there are choice in the transition. So that is why we are having here the power set of Q. So what is the power set? Anyone knows what is the power set you would have studied in your mathematics? Yes. What is a power set? Anyone knows? Nobody? You would have studied, right? What is a power set?
Ma'am, subset of
Yeah. Subset of?
all sets including the null.
That is, it is the set of all subsets of a set, right? It is the, yeah, correct, good. Set of all subsets of, yes, including the empty set, very good. So now from that, you will be having the output for the transition of this NFA. Okay, so that is why it is 2 power q. So if you have, for example, if you have number of states as q naught comma q1, okay, these are the, or 3 states you are having, okay, 3 states totally you are having, the internal states. So what is the power set? It includes the empty, right? It includes the empty set, and then you will have q naught, then you will have q1 separately, and then q2 separately. Then you can have q naught q1. Okay, you will have q naught q2. Then you can have q1 q2. Then q naught q1 q2. Okay, so the output will be any among this power set. That is the meaning of this transition function. Okay, so now you can see here what is that we are getting q1 q2. So q1 q2 is one of the subset of this power set. Okay, so I hope you understand. Do you understand? Can I get some response? Yes or no? Are you taking down?
No, ma'am.
No. Why?
I'm like, I didn't understand. Not getting.
Which part you are not getting?
Ma'am, before. Before, ma'am.
Before which one?
Yeah, from there. From there on top, from there onwards.
Okay, so don't worry. This is only now the definition. Okay, so when we again discuss about the problems, you will get more clarity. Okay, don't worry about this. This is definition of DFA and NFA. So both DFA and NFA is represented by this quintuple. Okay, so the machine, what is this? So what this definition says is that it contains a set of elements. Okay, what are all required for that machine to accept a language? We have a set of internal states, the input alphabet, and then the final state and the transition function. Okay, so all these are present. So I hope this example at least you would have understood, right?
No, ma'am.
See, this is the normal switch example, right? You know how a switch functions. There are only two things. You can either we can switch on it or you can switch off it. So on is a state, off is another state. So from on state, if you push, okay, you are pushing that switch. So that is the input you are giving. So if when you are pushing that, it goes to off condition. So if the switch is already is in off state, then again you are pushing, you are giving an input, okay? Then it comes to again on state. So that is what is DFA is, deterministic finite automata. You have a deterministic thing. Okay, Santosh, NFA is about, now do you understand DFA now? Santosh, do you understand DFA? Yes. So NFA is here, as we have seen, when in deterministic finite automata, we have a very deterministic output. Okay, a deterministic output is there. From this particular state, if you choose this input symbol, definitely it will go to this particular state. Okay, so that is very determined. But in the case of non-deterministic, we cannot say like that. It has some choices. Okay, it has some possibilities of different moves. So when we look into some of the examples, I hope you will understand. I'll quickly give some examples so that you will understand that. So as of now, as when I take the class, whether you understand it or not, try to copy down the problems and all the things I'm teaching you, so that even if you don't understand now, again you can play the video recording that is available in the Google Classroom, and you can try to get it. Okay. Okay, I'll give you a simple example on DFA. Okay, so we want to, the problem is that we want to find a DFA that recognizes the set of all strings on sigma is equal to a comma b. The alphabet that we have taken here is a comma b. Okay, and starting with the condition given is starting with the prefix a comma b. Okay, I'll give this example and stop this, and tomorrow and in the next class we will again discuss about the differences and the examples on NFA. Okay, so you just look into this example DFA. So what is asked is, you want to design a DFA, or you have to find a DFA that accepts all the strings, okay, starting with the prefix AB. Sorry, not A comma B, it is AB. Starting with the prefix AB. See, when sigma is given as A comma B, your sigma star can be, what is sigma star actually? Sigma power 0 union sigma power 1 union sigma power 2 and so on, right? So you can apply the alphabet any number of times. If it is applied 0 number of times, then it will have lambda, okay? And then union, if it is applied only one time, then you will have only A alone you will be having, then B alone you will be having. Okay, if it is 2 times repeating, then the length of 2, the strings of length 2 will be included. A, then AB, BA, BB, okay, and now including powers of 3, okay. So when it is repeated 3 times of length 3, then when you will have still more choices, AAB, ABA, ABB, so on, okay. There are several choices. Now, what is the language asked? The language asked is that set of all strings starting with the prefix AB. Okay, here you have several choices, but what is required? This language should contain only the strings which is having the prefix AB. Okay, so AB can be a string. Okay, you can take this string itself. It is starting with the prefix AB, and you can have ABA, you can have ABB, okay. Then you can have AB, then ABBA, ABBBB, so on. Okay, so there are plenty of choices. Okay, this is what the language it is required. Okay, this is the language given by the condition. Set of all strings starting with the prefix AB. So in all these strings, the prefix is AB. Now we want to design a DFA which accepts all these strings given in the language. So how can we do that? So let me have an initial state. Let me take it as Q naught, okay, a state Q naught. So what is required is A and B are mandate, okay. In your string, A and B are mandate. So how can I do that? On reading A, I go to another state Q1, okay, and on reading again B, it goes to a final state. Okay, this is the minimum. Okay, the DFA is not yet over, I'll tell you. So this is the minimum string for which I have drawn this DFA. So what it says, from starting from the initial state, on reading the input A, it goes to state Q1, and on reading B, it goes to state Q2, which is considered as the final state. Final state means it accepts that string. Okay, the machine has accepted this string. Okay, but this is not the only string present in this language. Okay, this is the minimum string that is present. So in DFA, what you have to keep in mind is that in every state, from every state, you should have transition for all these symbols in the given alphabet. Okay, you should have transition. Now you have a transition for symbol A. Okay, now you have a transition for symbol A, but you do not have the transition for symbol B. Okay, so but can the string starts with B? According to this language, can the string from the initial state, can it starts with B? Yes or no? What is the condition given? What is the condition given for this language? It should start with the prefix AB, correct? So from the initial state, is it possible to read, is it okay to read symbol B? No, right? Very good. So you cannot, so if you are reading the symbol B from the initial state, then that means this is not a string acceptable by the language. Okay, so that means it will never reach the final state. Okay, it will go to a state, we can call this state as a trap state. Okay, because the symbol that it is starting from initial state, it is not the one that is required for this language. Okay, it goes to a it goes to a trap state. We can call this as a trap state. Trap state means from this state it will never come back. Okay, it will have no outgoing edges. It will have no outgoing edges, but it can have a self loop like this. Okay, so after that it can, if you have some string like BAB or BBB, anything, okay, if whatever string that comes, the machine will not accept. Do you understand? The machine will not accept all these strings. Why? The condition for this language is it should have a prefix AB. So this will not be accepted by the machine. So this we need to design it. Okay. So if you when you are giving an input to the machine, if that input starts with B, the machine should say that it is not accepted. Okay. So that is why we are giving a trap state here. Now coming back, so for this state Q naught, we have both A and B, transition for inputs A and B. But coming to state Q1, we have transition from to only using input B, okay, and not A. But now you again think of, so already we have read an input symbol A, okay, from the prefix AB, we have read A. What should come next after A? Definitely it should be B. Okay. So now we have read A. From this state, what if A comes again? What if A comes again? Can it move to a final state? Because you should have a prefix AB, A followed by B. Now A we have read. When you read B, it will go to a final state. But again, if you are going to read A again, okay, A again followed by A, then again it goes to a trap state. Do you understand it, ma? Based on the condition given for the language, we are drawing the DFA. Okay, so what is the condition given? AB should be the prefix. So first, from starting from the initial state, I'll read A and followed by 1B. Then it means that the condition is satisfied. So we can safely go to the final state. But if it starts with B, okay, then it will not reach the final state. It is not a correct string. It is not a string corresponding to this language. Similarly, after reading one A, if another A follows, then that is also not a correct thing. So that means when the second A is read, it goes to again the trap state. Okay, and then so here also now we have drawn both the transitions. Now after coming to Q2, now you can have any number of A or B. Okay, it can be any possibility. After having this AB as the prefix, it can be AB or it can be BB or BAB. Any possibility can be there. So that can be represented using the self loop. So it is nothing but the star. Okay, so it is representing any number of strings that could be formed out of this AB. Okay, so this is the final state now. Do you understand this? Can I get some response? Yes, Nancy, yes, very good. Others? Only one or two are present in the class? Okay, so you just make a note of this. We will discuss more problems and more examples in the upcoming classes. So then you will be able to understand better. Okay, so I'll also post this recording in the Google Classroom. So when you find free time, you just go through it again so that you will get more clarity on this. Okay, so I think it is already time. So let me check once. Okay, so do one thing, you put your register numbers in the chat box and you can leave the class, so that I'll take that as the attendance. You can put your register number in the chat box and you can leave the meet. Thank you, students.